So just to reiterate, you have been graphing lines for your whole history of graphing, but we need to look at a brand new type of thing to graph, and it's called a quadratic. Now, quadratic, basically, when you graph it, will turn out to make a U shape. And there's a special name for that U shape. It's called a parabola. A parabola. I'll write the word, but we will take a long time looking at them, and I'll write the word in another one too. But it comes out to be a parabola, which is basically a U shape. Okay, so that's the special name for the shape you get. With linear graphs, you've done that for so long, since Algebra 1, pre-algebra, it was in y equals mx plus b form. Could be written in standard form. Quadratic is different. What do you notice that makes this one different than just something times x plus a number? Like, it's not an mx plus b, there's another part. What's the other part?
The squared.
The squared part. Okay, remember f of whatever can just be replaced with a y. So this really could just be y equals ax squared plus bx plus c. Okay, remember, this is just function notation, which really just means a y. For a line, this is a quadratic. Linear, this is review, but you're very familiar with that. Linear would be y equals mx plus b. If we wrote this in the same function notation, it would be f of x equals mx plus b. You have done enough graphs of this form so that you should really know them very well. You'll always get a straight line. You'll always get the same basic shape when you graph an equation that's in this form. A, B, and C are numbers, but in order to get that U shape that I'm talking about, and we'll do some very careful graphs later, in order to get that U shape, it has to have a squared term. That's why there's this little addition here that says when A doesn't equal 0. Okay, so this part can completely drop out. That can be 0. The C part can completely drop out. That can be 0. But it has to have a squared term in order to be what we call a quadratic, to get that special shape. Okay? Notice it's got 3 terms in it, and each one of them has its own special name. So we're doing just a little bit of vocabulary here. Okay? This is the same top part. I just broke it down. Ax squared, bx, and c. Pardon me? Okay, this part right here was just review. You don't really need that in your notes for right now. But you need to know just this part. This is a quadratic function.
Okay.
Okay. Okay, good. All right, so there's 3 parts here. There's the squared part, there's the part that doesn't have a square, and there's the C part. Okay, they each have their own name. This is actually called the quadratic term. This is called the linear term, and this is the constant term. The quadratic part, quadratic term, the linear term, and the constant term. And part of the very, very beginning questions ask you to put them in this order. So you've got a squared part and a linear part and another one, and then to identify each one. Okay, so for example, if you had the equation f of x equals 3x squared minus 2x plus 5, which would be the quadratic term?
3x squared.
3x squared. So 3x squared would be the quadratic term, and it's easy to identify. is the quadratic term. And which would be the linear term?
Negative 2x.
Negative 2x is the linear term. And the constant?
5.
5. 5 is the constant. Now, so far, not hard, right? So we have a linear, we have a constant, we have a quadratic. As long as it has some kind of a square in it, you're going to end up, if we graphed this thing, we'd end up with a U type of a shape. Sometimes it's a side, sometimes it's an upside down U, but we'll end up with a U type of a shape. So the first thing that you might be asked to do would be to rewrite the function in what we call quadratic form so that it looks like this. Okay, so I had started to type a direction and it seems to be gone.
Oh my goodness.
I'm going to have to retype the direction, so that's okay. So the direction would say write each function in quadratic form, then identify the quadratic, linear, and constant terms. Okay, so let's get an example of that. Let's see, number 1. Let's say we have f of x equals x plus 4 squared minus 13. I'm making it up. Now this is not in the right form right now, is it?
Nope.
No. Because you don't just have something times x squared plus something times x plus something else. So we're going to have to do something to get it into that form. In other words, we're going to have to multiply this out and put like terms together. Foil it, absolutely. So this one, huh?
We can do it in our heads.
If you're good at doing it in your head, absolutely, do that in your head.
Squared.
Sorry.
Plus 6.
Reduce.
X
So-
squared plus 16.
Now it's not just x squared plus 16.
Brain.
Remember, be careful when you have a
Plus
squared.
4x.
X squared, first terms, outers, plus 4x, plus inners,
Plus 4x.
plus 4x, plus 16.
Yeah.
Really, really important, everybody, that you take away with you out of this class that this does not turn into x squared plus 16. If we can break everybody of doing that, then it'll be a big success on this whole squaring binomials thing. You have to do them out so that you do not lose the middle term. So we're still not quite in that form. We've got things you can put together. So you combine your like terms. X squared plus what?
8x.
8x, because the 4 and 4 can go together. And can these go together?
Yeah.
Plus 3. So this is our quadratic form. This is this.
And with that,
That's this part. Now we need to identify the quadratic, the linear, and the constant terms. So the quadratic one here is what?
Easy. Quadratic equals.
The quadratic term is just x squared, right? Jonathan, what's the linear term?
X, just X. What could be it?
What's
8x?
8x? 8x. It's the whole thing that's in that spot, and then, wait, that's not linear. What is it?
Linear term.
It's not the linear term. Which one is it? Oh, yeah, it is.
What did I say?
What's the other one? Sorry.
You tripping. 3 is the
Constant term.
term.
Constant term. Sorry, the brain.
You tripping. You tripping.
Friday.
Yep.
Friday, don't worry.
It's Friday.
Sundays are coming.
Sunday's coming.
Sunday.
All right. Anyway, so the quadratic term, the linear term, and the constant term.
Not reference.
You put. All right. So you put them on here. First you simplify, then you split them out. Let's do another one just so that we've done a second one.
No.
No? Yes. Let's do the second one just because. Just because we can and we should. Oh, okay. I know which one I want to do. All right. Here's the second one. Same directions. Same directions. So let's do g of x. That's 2. Yep. Let's do x minus 3. Let's do a squared again. Plus 6x minus 15. Let's do that one. All right, so same deal. What do you do first?
You do the thingy, the x squared, the square.
Good, we're going to square this term first. So,
X squared plus
and
6x. No.
yeah,
Yeah, plus
Well-
6x plus 9.
it'll be minus 6x. So you're getting close, Preston, to being able to do that
So close.
as a pattern. So first terms are x squared. Outers are minus 3x. Then another minus 3x. What's this part, the last term?
Plus 9.
Plus 9. We still have our plus 6x minus 15.
Oh, snap.
Okay, so exactly, Charles. The x's will end up canceling out. If you try and put minus 3x plus 6x,
It's like when you have a 0.
you get, it's
Zero.
gone, right?
Just
So
put
it's
there.
0
Put there anyway.
So just put, minus 9.
minus, plus 9 minus 15 gives you minus
Negative
6.
Oh.
So this is actually your simplified form.
So it's like
Okay.
x squared.
Yeah, what about the 6x?
Negative
The
3
linear
and
term
negative 3 gives you
is
negative
0.
6. Then add plus 6, and it gives you 0x.
The linear term is 0.
Okay? So
Where's your linear term 0?
this one, and this one, and this one to give you 0, you just don't write it. When you're simplifying, you wouldn't write 0x.
So that's
What if they asked you what the linear term was?
That's the thing, is that we are asked for that. We're asked to find the quadratic term. The quadratic term here is what?
It's x squared.
X squared.
This is pretty good.
X squared. Let me do this. And then the linear term is the one you have to watch out for here.
I know what it is.
It's 0x.
Wow.
We don't write it when you write the simplified form, but that really is what the linear term is.
It's so simple.
And then the constant term,
Negative 6.
So
Is that OX?
Ox.
0 times x. And the constant term is
negative 6.
negative 6. So even if it doesn't show up, I mean, you could have linear and constant terms both being 0. Okay, if there was just a squared term, just a quadratic term, and it would still be a quadratic function. Okay, so we haven't really done anything as far as graphing goes, but what we have done is we've laid a little groundwork, so at least you know what a quadratic function is. So what I'd like to do is I'd like to, well, that too, but what I would like to do is I'd like to start us graphing these things.
Let's
So
do this.
let me pause this for a second.
Mm.
All right, so we're going to go way back to when you first learned to graph linear equations. When you did that, we had an equation and you filled in numbers and then you figured out where the different dots went. So let's look at the very simplest kind of quadratic, y equals x squared. That's the very simplest quadratic. Pardon me? I'm putting it over here so that we have enough room to make the graph. So what I want to do is I want to get us a little table. We're going to make an x and y chart because it is a function. Absolutely, it's a function. And we're graphing this linear function. So we're going to get some values here. Let's start with 0. When x is 0 and you plug in 0 here, 0 squared is how much?
0.
0.
Easy one.
What about 1?
1 is 1.
1 squared, 1 times 1 is 1.
Oh, what about 2?
What about 2?
4.
2 squared is 4.
Hold on.
And 3 squared is
9.
9. Alright, now we're not going to go up any further, but let's head into the negative zone for a minute. Negative 1 squared.
Positive. No. Yeah, positive.
Okay, positive 1.
Wait. Oh,
Negative 1 times negative 1, remember, is 1.
Every time a negative is a positive.
Right.
Yes, no.
Negative 2 squared is how much? 4. Negative 3 squared is... Okay, now, what I want you to notice here... Okay, what I want you to notice here, when you have a quadratic... Pay attention. Whenever you have a quadratic, whenever you have a squared term, what you'll find out is there will be some point where the values start to turn around and you get the same list of values again. Okay? Like here, the turnaround point is really at 0. You go in the positive direction, you get 149. You go in the negative direction, you also get 149. That will happen every time you have a quadratic function. Now, the turnaround point won't always be 0.
We're gonna have to do that every time we do a graphic.
We're gonna learn some shortcuts. You know how when you learned the linear graph, the first thing you did was make lots of charts and plot lots of points. That's where we are right now with quadratics. But then afterwards, you learned that the b was the y-intercept, and you learned that m was the slope, and you could do shortcuts. We're heading for shortcuts with the quadratics.
Okay.
But for right now, we're doing this the long way, just so that you can learn how it's supposed to look. So we want to make a graph.
How are we going to make a U?
Well, we're going to graph the points. So I'll have to move that over in a second. But you're going to make your nice y-axis.
Nice y-axis.
Oops. Well, what just happened? There we go. And we're going to make a nice x-axis. Now notice my x's are only going negative, just going 3 to negative 3, so I'm not making my x-axis particularly long, but my y, I'm going all the way up to 9, so I want to make sure I leave enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I can get away with going down here. So we're going to make sure you draw your graph. Now remember, we need to label our x and y axes. Okay, you remember this? Is this seeming familiar to you as far as graphing?
Yes.
All right, so let's plot some points. This is the ordered pair 0, 0. Goes right here. This is the ordered pair 1, 1. Goes right here. It's the ordered pair 2, 4. 1, 2, 1, 2, 3, 4. And this is the ordered pair 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah.
Now what I want you to notice is this is not making a straight line. It's a curve. It's not supposed to make a straight line. Let's check the other ones. Negative 1, 1.
Anything they say.
It's like a
Negative 2, 4. It's exactly a mirror image. As a matter of fact, I'm glad that you noticed that, Preston, because it's a symmetric figure.
Good job, Kristen.
Symmetric. So it's a mirror image, just like that. So there's actually, this axis cuts the mirror, that's where the mirror is. And that's going to be a very important thing very shortly. We're going to talk about that is one of the key features, is where the U is cut in half. Charles? It looks more like a V, but
But it's not.
we can't. Okay, now look. If we were to, let's get in a couple of these fractions, because I want you to show that it is more of like a U shape, because we can't just connect the dots here. What if we had a half? What if you have a half squared? How much does that give you?
Oh no.
1/4. A half times a half is a fourth. So if I go over a half, I'm not going all the way up to here. I'm only going up a fourth. Right here.
It's like a curve.
Yeah.
And if I do negative a half, we're going to get positive a fourth again. So once again, it's down here, and then you can start to see the U a little bit better. It's more like a U shape. Okay, so doing those, and so if we sketch in the graph, now this is the trickier part. It's going to be trickier for me than for you. But if I start kind of connecting these and making it fleshed out a little bit, we go up here, and we end up getting a U shape. Like I said, it's more difficult to do on this than it probably is for you. Probably. So I'm going to have to go down this way. Ah, okay, here we go. Oh boy, I'm really having a hard time with this. And now this thing is, remember, just like in a line, it's going on forever, and it's still making the U shape. Here we go down like this, making our nice U. Oops. It's actually technically neither, Charles. It's called a parabola. And the pattern will always be the same. It makes this nice, and now it is a curve. It's not really straight at any point. It's a curve. And it's called a parabola.
Okay, I see that.
And that shape is the same general shape for all the quadratic functions. Now it will move around on the graph. Some of them might have the bottom of your parabola starting over here. Some of them may have the bottom of the parabola starting over here. The parabola can actually be turned upside down.
Oh, really?
And that's what we're going to do, is we're going to look at various different parabolas and where they go on the graph. But it's important for you to recognize parabolas, for you to recognize how these things come out. Preston?
Permission to call that a parabola? That just sounds so much better. Parabola.
Parabola?
Yeah.
Oh, well, it sounds almost the same to me, so
Parabola.
that's just fine.
It's like an ah sound.
It's like an aw sound?
Parabola.
Parabola. Okay.
Parabola.
All right. Fine. Let's do another one. Let me see if I can find one that's going to be good for us. There we go. Let's do...
We've crossed into the great unknown.
May I have your attention, please? Please dismiss the girls' varsity.
Let me get a new one up here. I want you right now to do this one. We want to try y equals x squared minus 6x
Oh, I got this. I know how to do it.
plus 9.
Actually, don't know how to do it.
Now, on this particular one, I want you to use your x values as being 1, 2, 3, 4, 5, 6.
Wait, what? So we're gonna have multiple of these?
I want you to, I'm choosing your x's for this one. I want you to choose your x's to be 1, 2, 3, 4, 5, 6. I want you to find the y's, and I would like you to graph them.
Look at you.